So thank you for staying. Ben tried to convince you to go to other rooms. Thank you. They didn't listen to you. Good job. So yeah, I'll do my best to wake you up after the lunch. I'm in food coma myself, but we'll try to figure something out. All right. So yeah, surviving the tech apocalypse. What are we talking about? Basically, it's bad out there. It's been bad out there for a couple of years. I guess that was the talk supposed to happen last year, and we have another year of data. It didn't get better. Well, it did a little bit, right? So if we're looking at the layoffs in 2022, more than 150,000 people, and then more than 250,000 people last year. And this year, it's been a rough ride as well. We're not done yet, and we're already getting close to 150,000 people. Basically, more than 500,000 people were laid off in IT, technology, high-tech, whatever you call it, in the last 3 years. This is a lot of people that been laid off, but this talk is not about them. This talk is about people that actually survived and what does it mean for them. Before we go into that, I want to talk in general about the whole notion of layoffs for the sake of cutting costs and raising the stock value and all this stuff. And what I want us to think about is something that is very, very related to DevOps through a very interesting connection. So, how many of you know the book, The Phoenix Project? I guess everybody, well, surprisingly not everybody, but if you don't, you really should. If you look to read one book about DevOps, that probably will be it. And the beautiful thing about The Phoenix Project is that it's a novel. It's an entertaining book. It's a story about a person who kind of started to work in a company that struggles and then invented DevOps and turned the company around, leading it to success. That's kind of the premise. The interesting part about the Phoenix Project that is based on another book called The Goal. Now, who heard about The Goal? Even less, which is understandable. But I would argue that this book is not less important, if not more. This is Dr. Eliyahu Goldratt, who invented what it's called the theory of constraints. And a lot of stuff in DevOps is based on the theory of constraints. A lot of stuff in the Phoenix Project, the book, is based on the stuff in the Goal, the book. Now, all right, we can change the microphone. Okay, so yeah. I prefer the other one, but, you know, we'll make do. So, yeah, what I was talking about, the Goal, right? So, the Goal is structured in a very similar way, or should we say the Phoenix Project structured in the similar way to the Goal, and it's also a novel about a person who came to work in a failing workplace, invents the theory of constraints, and turns the company around. Now, the Phoenix Project actually pays homage to the roots of the Goal, and the advisor to the main protagonist in the Phoenix Project actually pushes him to invent DevOps by telling him stories from the Goal. It's all very interestingly connected. And the reason why we're talking about the Goal is that one of the main principles that Professor Goldratt was talking about is that companies should move from the cost world to the throughput world. From the place when cost is the most important part of the business value to the throughput as the most important part of the business value. Because only through maximizing throughput you can actually make your business success. Because throughput is based on inventory, and inventory rots, in the terminology of Eliyahu Goldratt. Rot, it means that if you have inventory that you don't move and you don't create throughput out of it, it's not only not making you money, it's actually wasting your money. And between throughput and inventory, cost is the less important part. How much money you spend on operational stuff is much more relevant to the success of the company than those two. Inventory that you have to move and throughput that you actually do to move the inventory. So inventory is a material that you have to convert to throughput. Now, if we look at that and do the same step that we did with the theory of constraints to DevOps, and look at what does it mean in terms of IT company. So what is throughput? Throughput is the software that we write, right? Throughput is the money that we make. Now, inventory is the software that we write. This is the code. If our sales, marketing don't sell the code that we write, then the inventory, which is the code, rots, and we don't make any money out of it. And the cost is still cost, like it's organizational cost. It's basically salary. If we are talking about IT, this is the most important cost that there is. Now, remembering that the most important thing for the company is moving code through sales and not the cost, which is the salary, you can understand that the only initiatives that positively impact performance are the ones that increase throughput while simultaneously decreasing code. What we need to make sure is that the company writes more code, and it's more important than minimizing the cost. Minimizing the cost is important, but if we don't generate more throughput by writing code, we are not serving our company, and obviously the managers don't sell their shareholders. So cutting costs, layoffs, without increasing throughput by moving inventory, creating and selling more software is useless. It's actually harming your company in the long run. You decrease cost, it's important, but on the way, you lose the ability to move your inventory and create throughput. So yeah, layoffs are short-term solutions for your next quarter stock, but in the long run, they are very bad for your company, for the company, whoever it is. There is a good kind of reason all this silent quitting when we discover that people who are allegedly working from home actually not working, and they are not working and getting salary from more than one company, and all this kind of stuff. And you can see here a research from Gallup from April this year. US engagement hits 11 years low, right? And engaged means basically they're sitting at home and not doing anything. So isn't it a good excuse for letting people off? Well, yes, but actually this is not what's happening. Because then you would expect selective layoffs. You would say, okay, we found a way to measure the engagement. This is something that Gallup does, so there is a way. And then we will fire those who are not performing well. But this is not what's happening. The horizontal layoffs, we will lay off 10% of our workforce, is not that. It is actually something like that. Lay off lots of developers, you see momentarily bump in stock, and then actually you try to push less developers to deliver the same roadmap, maybe with help of AI. Obviously, what can possibly go wrong? Now, I don't know if that's just me, or maybe you feel it as way, but the state of software is not great. I mean, I try to check in online for my Archaea flight. And then I try to browse like Twitter or whatever, x.com, while waiting for the flight. And then I try to do something else with software, and it's all crap. Software is really bad. Maybe it's my nostalgic views, but I don't remember it being so bad that it is now. And this might be one of the reasons why. My name is Baruch Sagodursky. I'm at JBaruch and everywhere in socials, whatever, Twitter, Blue Sky, whatever you use today. And I'm a developer productivity advocate with the company called Gradle Inc. I've been in the industry for many years, doing developer relations roles in a company called JFrog that you might have heard about, considering it's those days Tel Aviv. Spent there 11 years, and also I help companies do developer relations, being developer relations advisor with a lot of companies, a lot of them in Israel. If you need some help with developer relations, talk to me. We can do great stuff together. My personal journey, I started with development, being a Java developer back in the day, and then together with JFrog, we kind of pivoted to DevOps, and now with Gradle, developer productivity engineering, hashtag DPE. I wrote a couple of books, DevOps tools for Java developers, which is both DevOps and Java, and Liquid Software, about how we really should release software so it won't be as crappy as it is right now. The most important slide of this talk is show notes. If you go to speaking.jbaruch, you will find there the slides that are already there. The video we are recording, right? We are. So you will have the video soon enough. And all the links for everything that I'm talking about, including the Phoenix project, if for some reason you didn't read it, and the goal, which most of you didn't, but you really should. It's all there in the links. Everything that I'm going to talk about there, it's all there. To make it very easy for you to remember, it's in the bottom of every slide, right there, speaking.jbaruch, together with DevOps Tel Aviv has a handle that you really should mention when you praise this talk, together with mine, and hashtag DPE for developer productivity engineering. All right, let's talk about layoffs. Well, let's do some human resources speak crash course. In human resources speak, there basically when people leave, it's called attrition, and there are 4 types of attritions. There is the regrettable voluntary attrition, which in human speak means someone quits a company and the company is sad about it, right? So it's voluntary, they wanted to leave, and it's regrettable, we kind of, we wish you stayed. Another type of attrition is voluntary non-regrettable attrition. It's when someone leaves and we don't feel sorry about it. And then there is involuntary non-regrettable. This is basically when someone is fired for their performance. And the one that we are going to talk about, the regrettable involuntary attrition. Right, is those layoffs that we know that we lay off good people because we want our stock to go up in next quarter. And spoke about not very smart. And the problem with involuntary regrettable attrition is that because it's not based on any performance issues of whoever is being laid off, it generates a lot of negative emotions in the people who stay. Now, let me ask you, considering that we are past 500,000 of people who were laid off, I bet most of you have colleagues who've been laid off. This is the word cloud of emotions that people feel when someone is get laid off and they actually survive. Is that on point? I know for sure that it's sounds very about right to what I feel when other people get laid off. Anyone else feels that way? Right? Yeah. So, I have colleagues that left, that were laid off without any good reason. And when I stay, I start thinking about why. What are the chances that they won't let me off? is there anything I can do differently that will protect me? Probably not. This is a lot of emotions, and those emotions are pretty universal. Actually, the leadership IQ survey, the one that you are looking at now, was actually done after the previous economic crash in 2008. This is like a 15 years old survey. And it feels very relevant because actually nothing changed. And it's more than 4,000 people were surveyed. Of those who remained from 320 companies, it was a good survey that is still very, very relevant. And when you look at those emotions, they look very familiar to something that, unfortunately, all of us know, especially now in Israel, the survivor guilt. Those are the same emotions, obviously in a completely different setting and probably on completely different levels. And it's basically not great to compare the two. So this is why David Neuer, who is advisor for the companies in those scenarios, came up with another term that it's called labor survivor sickness. And layoff survivor sickness is exactly that. Is when people who stayed feel bad when other people get laid off. Now, he wrote a book about it. He's an organizational consultant that comes to companies that experience the sickness survivor, the layoff survivor sickness, and try to fix stuff. And obviously, you know where to find this book. You go to speaking.jbaruch and it's there. So yeah, layoff survivor sickness. Now, I showed you a very old research from the previous round of layoffs from 15 years ago, but it's absolutely the same right now. So if you look at BizReport, which is doing this similar survey for this wave of layoffs, it's pretty much the same. 75% of labor survivors say their work motivation has declined since the layoff. And then if we look back, it's absolutely the same. 74% 15 years ago said exactly the same thing. Since the layoff, my professional productivity has declined, right? Since the layoff, from what I've seen, the productivity of my coworker has declined 64%. So basically everybody agree, and if you look here, 65% of layoff survivors say they have overworked since the layoff. And that's the exactly part when the rest of us need to pick up the slack and keep producing more and more features with less and less people, right? So basically, it's all sold to us, but hey, we need to be lean and mean organization with downsizing to be leaner and more effective and what's not, but it's actually sad and angry organization because people are really sad and really angry and they don't see the way forward or how can they be protected from those layoffs. But for the organizations, the show must go on. And for us as well, in the end of the day, we don't want to stay sad and angry. We want to be happy and productive. So how can we do it? Well, that's the default way, right? So the default way will be your carrot and a stick. And basically, if you don't perform under those terrible conditions, we will fire you as well. And then obviously that will be whatever unregrettable, involuntary, you're fired. But it doesn't have to be. And we can find a better way if we look into the motivation of the survivors. One of my favorite books of all time is Drive by Daniel Pink. It's a research into what motivates people beyond the carrot and the stick. And what Daniel Pink is saying is that, hey, obviously money is a great motivator up to a certain point. When there is enough money and the question of money is not on the table anymore, money stops being a great motivator. Yes, we all love to get a raise. And yes, it will motivate us for the next couple of weeks or a couple of months. But in the end of the day, this goes away. And what's left are those three factors. autonomy, mastery, and purpose. Now, when you concentrate on those, you can overcome the layoff survivor syndrome and make the people who survived actually productive, so not only they can do their job better, they can try and overcome the much less resources that they used to have. So here's an example of autonomy that is ruining our work. So let's say you have a build that takes forever and it's distracting. I'm doing something else, and then I'm switching the context, and then I don't even remember what I used to do before I did what I had to do. And those types of developer pains are extremely widespread. In the survey that we did with Gradle, we find that 84% of developers are really complaining about how much time they spend waiting on a build and test feedback either locally or during CI. And I bet if I do show of hands here, you will tell me that. Who's happy with how fast their build is? I expect 50%, well, I get 0. Well, yep, you get the point, right? Not only that, the tooling that frustrates the developers is really demotivating. So stuff like flaky test, flaky. Flaky test is really painful because it's not your fault, you have no idea why it breaks, sometimes it passes and it ruins the entire build, and this is terrible and you are frustrated. And again, inability to easily troubleshoot and determine the root cause of build, test, and CI failures, including flaky tests, is something that 65% of developers agree that it's just bad, right? Or stuff like degradations, right? I used to have an environment that worked okay, but now it's really not. And I have no idea what changed. And frankly, I don't even know that something changed. It's just everything is slow and annoying and this kind of stuff. Again, almost 60% agree that this is the case, right? So developer productivity is very tightly related and correlated to developer motivation through those concepts of autonomy, mastery, and purpose. Right, so autonomy, I can do my job. And I'm not, tools and people are not in my way. I'm not dependent on something that is failing and I cannot fix, and then I cannot work and do my work autonomously. Mastery, we want to excel, but can we? Now I need to work with something very cumbersome and very buggy and something that I cannot master really, and it's obviously very, very annoying and increase my productivity. And speaking about productivity, productivity is the same, even the same word as product. And this is the purpose of why we are in this company. We want to be productive. This is one of the purposes that we are working in the company on a product that we are working on. So they're all very, very related, and there are obviously tons of ways to improve all three of them. Starting from well-being, from having some kind of safety in our workspace, which is exactly the opposite of just like blind layoffs and this kind of stuff. But there's also an engineering aspect to it. And since we are here at DevOps Days and technical conference, the engineering aspect of developer productivity is really fascinating, and this is what I want to spend the remainder 20 minutes talking about. So how can we engineer better productivity? That's an interesting question. So there are a lot of ways to go about it, a lot of concepts and tenets of developer productivity engineering, stuff like foster faster feedback. How can we make sure that developers get feedback on their work as fast as possible? Or stuff like eliminating toil for developers. All those processes and all those actions that are actually not bringing us any value, but are there just because. Or collaborating through effective tooling Speaking again about build, so now you have a failing build, and you need to send it to someone because you think that the other person is responsible for what doesn't work. What you're gonna do, you're probably gonna dump the entire output of the build into their Slack. Will they make it, is it like the most productive way? Probably not. Prioritizing automation and eliminating bottlenecks. This is straight from DevOps playbook, right? DevOps is about eliminating bottlenecks and automating everything. So we do it for our production environments as part of our DevOps culture. Do we do it for our development environment? We probably don't, but we probably should. Again, observability and proactive improvement. Another couple of concepts directly from our DevOps daily lives that we embrace completely for production. Do we embrace them for our development environments? Probably not, we probably should. Organizational mindset. This is very important. I'm going to touch about it later on. And again, this is kind of a solved problem of DevOps. We are at the biggest DevOps days in the world. You're all here because you understand the importance of DevOps. How about the importance of working, improving your development environment? Probably not, or probably should. The last but not least, outcomes over output. Again, same idea that we do very well with DevOps. Talk to any observability company and they will tell you this is what we do. We convert output to outcomes. You give us all your data, which is a lot of output, and we find the important outcomes of all the output. Again, we do it for production. Do we do it for development, for developer environments? We don't, we probably should. So let's talk about some very concrete examples of those tenets. So, and we're talking about small things that you can actually start doing today, and it will make huge difference in your productivity, and at the end of the day, contribute to your well-being while being a survivor. Just use better ID. How about that? When you generate code, when you write code, just use better ID for that. You're already probably doing it. Good job. Testing. Stuff like using test containers as the testing framework instead of waiting hours and days for available testing environment that uses the real databases and streaming platforms and what's not. You can emulate those with test containers using Docker, and it makes the life of developers much easier and they are much more productive. Quality of code. Again, there are tools that automatically can improve the code quality, and it will make your life easier in the end of the day, stuff that Sonar does. Flaky test detection. There are tools that know how to detect flaky tests. One of them is from Gradle called the Velocity, but there are also others, and I don't mind what you use as long as you detect those flaky tests. A good start would be just when you retry flaky tests, record your retries. And you will know that there is a flaky test and it might be a problem there. And foster faster feedback, something that I start with. Let's talk a little bit about that. So, what is feedback? And what is feedback efficiency? So, you have expectations from feedback efficiency. When you write code in your IDE, VS Code, whatever, you expect to see results of your code immediately. If it doesn't compile, it will mark it as not being compiled, and then obviously you know that you did something wrong. Build. You expect your build to be very, very fast because you want the results to see them immediately while you work on your code. And then you have your CI, which will take minutes, half an hour, whatever it will take, and then production. Now, production is the way to get feedback, right? I would also argue that it's the really true way to get true feedback. In the end of the day, the only quality that matters is the quality that people encounter in production. And um, it can take longest time, but it's still very, very important. Right? Now, if you look at those items and put them on a scale, you can see that the more feedback is closer to developers, the faster we expect it to be, which obviously makes perfect sense. And it kind of also works this way, probably except of the build phase. The build phase is significantly slower than what you would like it to be. Everything else is kind of fun. And, you know, it's true because XDC has a comic strip about it. And this one is really annoys me because it shows that slow builds are fun. They're not. They might be fun for the first time, but then they're not. They're really not. So the first time is very fun. The next time is really, really annoying. Build is slow is really annoying the developers. Now, the problem that annoys the developers is that build is an entirely different domain for most of us. Who knows their build system really, really well? Kind of all the in and outs, and know how to troubleshoot it, and know what to do when it fails. Well, there are a couple of hands. That's exactly my point. Most of us don't, and are not expected to, and really don't want to learn it because this is not their domain. And it's fair enough. It's not only slow. We don't have a good way to speed it up because we don't understand why it's slow, because it's not our business. Let's try and figure out what can possibly go wrong. So what is build? Project setup, and then downloading the internet, all the dependencies, and then we generate artifacts. It might be compilation for compiled languages, or just packaging for the non-compiled languages, and then we write a bunch of tests on it, and then we generate the artifacts. The artifacts that we generated, we store them somewhere. Probably we don't deploy to production from our local environment, but we do something with the artifacts. Now, what can possibly go wrong? Project setup, downloading the internet, artifact generation, tests, and artifact deployment. Basically, anything can go wrong, and it also can go wrong at any time, which doesn't make it any easier to debug. So the build really frustrates the developers most of the time, and there is no easy way for us to actually do something about it. Now, if you want to speed up the build, you go and ask ChatGPT, so I did. What are the techniques that are used to speed up a Maven build? The first result, the first suggestion is skip tests. Not great. Tests are one of the most important ways for us to get feedback on the work that we do. Skipping tests defeat the purpose of the build. We do local build not to get the artifacts to deploy them to production. We don't deploy local artifacts, but to get feedback. And the feedback is, does it compile, yes or no? And are the tests passing? If we skip the tests, we actually defeat the entire purpose of running the build. If we skip tests, maybe we should skip compilation as well. If we have a Java application, let's just go and patch some Java files on production and try to compile them there, because if we don't care about feedback, we don't care about feedback. So obviously it's not great. We want faster feedback, not less feedback. So what feedback do we really want? Where can we look for a good list of feedback items that we want to collect? We can look at our CI/CD quality gates and look what they're doing and then say, okay, this is kind of feedback that we want. What do we have there? We have basic stuff like it compiles and the unit tests are passed and the integration tests passing. This is great. And then we have a deeper quality analysis like code coverage and linting, the quality of the code, static code analysis for quality and this kind of stuff. And then we can check security, dependency scanning, and secret scanning, and static code analysis for security problems and this kind of stuff. And we have the non-functional requirements, like load testing and resource utilization and compliance stuff, right? So this is a good list of feedback that will tell us that our quality is good. This is what our CI/CD pipeline allegedly does or really should. Now, we want the same not only in CI, because having it at CI, it's not bad, but it's also not great, because if we're gonna wait for CI to get this feedback, we will have to go back to what we did before we committed our code to fix when problems arise. We want the same feedback, but in another place. There are two types of feedback, asynchronous and synchronous. And asynchronous feedback, this is what our CI is. We don't wait for it, but if somewhere down the road we discover that something failed, we need to go back and fix it, and this is distracting because we're already doing something else. Synchronous feedback, like build, is great for exactly that. If something failed in the build, we are going to fix it immediately. But if it's slow, it's really annoying because we won't wait for it, we need to come back and fix it, and it actually becomes asynchronous, and we don't want that. We want build to keep being synchronous. And the line between the two is the commit time. Before we did the commit, we work on our project synchronously. We wrote something, we see the IDE will tell us if it's okay, and then the build will tell us and it's okay, and then we commit, and then we start doing something else. So this is kind of the line. So we want to take all that and make it synchronous. We want all those checks in our build time. And then you say, okay, but it probably will slow down the build, and slow build is terrible, as we just spoke. So what are we doing? We actually want both. We want maximum feedback, and we want it as fast as possible. So what can we do? There are a couple of techniques that are very easy to implement and will get you as much as possible to this combination. The first is skipping what you don't need to build, but no more. Remember, we want feedback, just the feedback on the things that really changed. So skip what can be skipped. How do we do it? For example, incremental build. Incremental build is something that every build tool today knows how to do. It looks on our project, and then it says, okay, you already built this module, and nothing changed in it. We won't build this module again. You also are not affecting the other module, so we don't need to run tests on the agile model. Again, this is something that is automatically done for you. The problem is that incremental build have shortcomings. It relies on produced artifacts to see if the artifacts were really generated. But if the produced artifacts are deleted, then it has no way to know whether this module has to be built or not. It relies on architectural decisions. You actually need to have modules that have dependencies between them described in the build. If you don't have that, it doesn't know what modules affecting other modules. Another way to avoid building, and it's much more powerful, is caching. This is where I have the Johnny Cash t-shirt. Right, so how cache works, it makes the build faster, exactly as incremental build, but it makes the build faster for everybody, not only for you. What happened? Okay, no slides for us. Here we go. Not only for you, because cache can be distributed. I can say, if I build this module and you didn't touch it, you don't need to build it. I will give you my caches, and your build will know how to skip them. It makes the build faster always, because it relies on caching results and not on the module structure. So even if you work on a monolith that in theory everything is dependent with everything else, if you use caching, it will skip the parts that don't need to be built. And it makes all the part of the builds faster because it's not only dependent on the produced artifacts. Actually, when we're talking about cache, almost every task in this list of what build is doing can be cached as long as you can express in inputs what this task is going to work with, and in outputs what this task is going to generate. Then this task can be cached, and this is almost all the tasks. Right, and you can see here as an example, this is a UI of Gradle the velocity, but what matters here are numbers. So you can see here, there is a project that builds for 12 minutes, here we go, 12 minutes and 28 seconds. And we have, it actually would be much longer, but we saved tons of time. We saved 40 minutes. How did we save them? So there is the up-to-date part, and the up-to-date part is the automatic savings of incremental builds, but there is also remote build cache of 20 minutes that was saved, and this is something that is pure gain from caching. So we saved double the time by using both incremental builds and caching together. What else we can avoid? We can avoid running tests that we don't need to run. How we do that? With a technique called predictive test selection. Predictive test selection is a machine learning algorithm invented by Meta that learns the code, that observes the changes in the code, and then learns what tests can we skip based on the code that was changed. So basically, code changes and test results are thrown in a learning model. It will learn by observing the changes and the test results. And in some point of time, it will tell us, okay, we know that those kind of changes in the code never fail these kind of tests. So we don't need to run them at all. And basically, what changed and where it's changed is learned, and then correlate with test results that are actually happening. And then we can say which changes will fail, which tests, and we can skip everything else. Couple of very interesting examples. Now remember this, the model doesn't understand your code. It doesn't know what your code does. It doesn't understand what programming language it is. All it does is it's observing given code changes, and then it's observing tests. And based on those two, it makes very interesting discoveries. For example, the more tests a project has, the less they break. It makes perfect sense for us because it kind of shows that this project thinks about quality, and then obviously the quality will be better. But the machine doesn't know it. Another conclusion, it's even funnier. Refactorings in Java break tests less than refactorings in JavaScript. You say, duh, because obviously one is statically compiled and the other is just a bunch of crazy random stuff that breaks all the time. But the machine doesn't know about it, right? It has no idea. All it knows is here is a bunch of files with .java as an extension, and every change there almost doesn't break anything. And here is another project with the .js extension, and the tests are always breaking. We have no idea why, but this is what we see, right? And again, this is surprisingly reliable. Here's an example from the Spring project, the velocity instance, and they run predictive text selection in simulation in learning mode. And you can see here that they predict with astonishing accuracy what is going to happen. 98.7% of the goals predicted. Now, if they will run it in production, not in the learning mode, but in operation mode, it will save them 61 days of build time in the last 3 months. This is very impressive. But then you can say, but hey, what about those pesky 1.3%? Can we allow to ignore them? And my answer would be, you don't have to. Because remember, you have CI. It's asynchronous. You don't wait for it. You don't care that it's long. So run all the tests in the CI. And catch this 1%. Yes, it will be distracting because you need to go back and fix something that passed on your local build because you didn't even run those tests because you expected them to pass and they failed. But this happens so rarely and the benefits are so huge that it's definitely worth it. Okay, so we skipped everything that we can skip and now let's speed up what cannot be skipped. In the end of the day, work was done and now we need to build the stuff that we created. So how do we do that? Test parallelization is the single most important thing to do. You need to use max power of the local machine in order to run your tests. And this is why your boss should buy you the bleeding edge of hardware because it's very important. Now, if you want to make a case to get your newest MacBook Pro, Max, whatever, Mac M4, I just show them the video. It's all there. And I have numbers to prove it. So here is a test that is running on my machine. And it takes 2 minutes, 1 minute, 59 seconds. I change one line of code in my build. And the same build now runs 10 seconds. This is, what, 2 minutes and 120 seconds, 12 times improvement. 12 times improvement with one line of code. Just use the maximum power of a local machine. And this is like M1, that's like 3 years old hardware. Take this video, take this part, show it to your boss, and the new MacBooks are soon to be released. That's a perfect timing to show them the video. All right, what else can we do? You know what has more computing power than my machine? The cloud. The cloud has all the computing power. So how about we take those tests and we send them to the cloud to get tests? This is similar to what CI does, and it's called fan out, but this is for your local builds. Your local build, during the time that it runs on your machine, can send the test to the cloud, run them in parallel, and get the results back in. You should enjoy it for your local tests, and the cloud can distribute the test load. And then you run all the needed tests. You don't skip the tests, you run all the tests that you need to run, but no more. All right, so CI, it will use it as well, but it's relying on shared CI infrastructure, and the CI infrastructure is not optimized to be fast because it's not optimized for real-time feedback, because CI is asynchronous feedback. We don't wait for it. So having the test running in the cloud is actually more important for your local build than for CI. Probably the CI agents are not as fast as they can be, but if you need a CI that runs it, then it's more important. I'm out of time, so I'm going to speed up a little bit. Don't let it slide. Observe and improve. Measure local build times is the first step to developer productivity engineering. Just measure how long your build times take, how long they take for your colleagues that work remotely when the internet connection is not great. Do they even know that they have a degradation because their internet not great? Not sure. Detect down-facing trends and find the root causes and improve. This is how boiling the frog looks like. It's a build time that crawling slowly, and then suddenly it's much slower than it should be. And the gains are real. Developer productivity engineering convinced from if implemented correctly improves productivity by 84%. And probably the same 84% report developer joy. I love this slide because it has the word joy on it. And what's the difference? This developer joy and the anxiety, the fears, and the stresses that we started with. This is what productivity does. You get from being depressed from your work to having joy at your work, and this is important. And then you say, okay, Baruch, that was a nice talk. I don't care about any of that. DPE is not my job. But yeah, this is a very similar argument that we heard, that DevOps is not my job. And obviously, this is exactly not the case. DevOps somehow is everybody's job, and it's the same with DPE. And I have a slide that explains that. We'll skip that for now. Start with focus teams, and the best organizations have them, and hire for those. Snowflake and LinkedIn and Microsoft and Spotify and Netflix and Elastic, all of them have teams that do exactly that, and the entire organization helps. So this is also very, very important. Just to summarize, fight downsizing Survivor Guild with developer productivity engineering. It improved morale from depressed and anxiety to joy. It covers productivity gaps. Less people can be more productive by using this. And then it's the right thing to do for both the employees and the business, and it requires organizational mindset and a dedicated effort. With that, you can learn more by scanning that. It will take you to exactly the same place, speaking.jbaruch, and then we can give you some prices for trying it, and you can be and should be the DPE agent of change in your organization. DPE handbook, the book that describes all that. You can watch the DPE Summit videos. We had it in September, and the videos are out there. And with that, thank you very much. At JBaruch everywhere. DevOps Days Tel Aviv. That's and speaking.jbaruch. Thank you.